Good morning, everyone. We are going to be talking about chemical equations. We're in the reaction rates unit of our chemistry curriculum. So we have to be able to talk about how to write chemical equations, because what we're looking at for chemical reactions is how can we speed them up or slow them down. That's really what we're looking at, but if we don't know what's happening chemically wise, then we can't really do anything else. So that's what we want to look at first. So we're going to go over these notes together. And I actually chose to not start prepared because I want to show you all something too, because I've been asking you to draw and use some other things. So hopefully on your Word documents that you can open, you can always go over to this draw tab up at the top and you can choose different pens to write with, right? You can even add a pen or a pencil, whatever you like. You can change the color. I'm going to use blue today. You can change the size of the pen. I'm going to make mine a little smaller so I can write easier. And you can just use your screen to click. You can write with the little cursor up here, or I have a touch screen, so I'm going to actually be using a pen, so you're not going to be seeing my cursor move around. But I want you all to know that this is an option, and you actually have a lot of fun pen options. There are highlighters, so I just want you to know that that is available so that you have that as a tool for your toolkit. So when we talk about formula equations, we want to show chemical changes or the rearrangement of atoms using chemical symbols or using a chemical formula, right? This is chemical symbols or formula. Oop, apparently I can't write over there. So I just want to give an example here, right? So if I told you that iron is reacting with copper sulfate to make copper and iron sulfate, you're probably like, I don't even know how to do that. But it's really easy, and we're going to break it down, right? So if I have iron, which we'd find on the periodic table is Fe, and then I'm going to react it with copper sulfate, Cu, which is on the front of the periodic table, SO4, which is on the back, and I will add the front and the back of the periodic table from our class onto the Schoology page, so you have access to those. Right, it's going to react. We use that arrow to mean reacts or makes or forms or yields. It's going to make copper and iron sulfate, right? So you can see that everything is still there. It's just rearranging, and we can visually see this. A little bit more terminology for you, right? This is called reactants. That is what is reacting. It is always the left-hand side of the equation. It's what you're starting with that is going to make whatever we end with. What we end with, right, if you go to the grocery store, you don't want to buy necessarily reactants. You don't want to buy, a rice plant that you have to put into the ground and wait for it to grow to get rice. We want to buy products. We want to buy just that rice itself. So just like at the end of a chemical equation, we write products because that is what we end with. And like I mentioned verbally, this little arrow means yields, makes, forms, produces. It's kind of like an equal sign in math class. So oftentimes what we get in science is we get these word equations. So we can show chemical changes using the names of substances. So a lot of people think of this as going from like English to Spanish or English to Chinese or English to Somali or whatever else, right? So we have our English version, right? Magnesium plus oxygen yields magnesium oxide. And then we want to translate it into chemistry version, right? So we have to go find our elements. Magnesium plus oxygen, and it's O2. We will talk in just a moment. That's the next portion. We're going to talk about why it's O2. React to form magnesium oxide, MgO, right? So I have magnesium plus oxygen. Remember, yields goes with my little arrow. And then I have magnesium oxide, my final product. So everything is represented in just little chemical forms. So some things that we haven't talked about in class yet, there are things called diatomic atoms. So these are molecules made from two identical atoms bonded together. Di means two, atomic means atom. This is only when the atoms are by themselves, right? So this isn't necessarily true in if if I have it with something else, right? So you can see up here that oxygen is a diatomic, so it's O2 when it's by itself, but when I put it up here with the oxygen, it doesn't keep that 2 because now it's with magnesium. It's not just by itself. So this is only when they're by themselves. And there are 7 of these on the periodic table. There's hydrogen, oxygen that we just talked about, nitrogen, fluorine, chlorine, bromine, and iodide. Right, so those are our 7. The way that a lot of people remember it is you can actually have hydrogen and then form the number 7 on your periodic table. So I challenge you to look at this later, but what it looks like is I have my hydrogen all the way over here, and then on my periodic table, I have boxes over here where I have nitrogen, oxygen, and fluorine. And then down below, underneath fluorine, you actually have chlorine, bromine, and iodide. Right, so you can kind of see that this looks like the number 7 on the periodic table. So that is how people remember it. The other thing that's important to think about is what phase of matter you're working with. So remember, if we're talking about water, you can have solid water, like ice. So if you were getting yourself a soda or lemonade, you probably want solid water in it and not somebody to put liquid water in it, because then it's going to taste funny. Liquid water we drink all the time, and then gaseous water is around us all of the time, but we also often think of it when it's steaming. So solid, liquid, and gas have abbreviations that we write into chemical equations. A solid is an S. Let's erase that and make it actually look like an S so you can see what it looks like when I'm not here. Can look like an S. A liquid, I know, shocking, is going to be an L, and gas is a G. The other thing that we can have in chemistry is aqueous. Aqueous means something is in solution or it's dissolved in water. So an example that we might think of in our everyday lives are sugar that we put into our tea to dissolve, or maybe salt when we make a big pot of pasta or something else. Just means that we can't separate these two anymore. They're dissolved together, and that stands for AQ. So there are 2 examples that I want to go through here. We've got hydrogen gas, right? So that tells you in the chemistry equation what state of matter we're looking at, right? So hydrogen, some of you will remember from above, it's a diatomic, so it's H2 because it's by itself. We can just put a little parentheses and say gas, plus oxygen, another diatomic, and it's going to produce, so I get a little arrow, H2O, and it's a liquid. I want to remind you that every element can end up in any phase of matter. I know that sounds really strange, especially as we think of things like iron or gold, but they can become a gas that just takes a lot of temperature and a lot of pressure. So this next one, solid magnesium chloride. So magnesium chloride is a solid. What's going to happen is it's going to fall apart into magnesium, which is a metal at room temperature, so it's a solid. I should have included that, and I will try in the future, plus chlorine gas. Right, so those are our general notes. If you got over here and we got to this magnesium chloride and you were like, oh my gosh, where did this 2 come from? You're going to want to watch the next video that's just going to talk about how we make these via the crisscross method, or if you just want a real refresher from ionic compounds, because that was all the way back in December, so that was a little while ago. Hopefully that makes sense. Hit me up with any questions if you have them.